a'udhu Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Today our topic is Earth's inner core is moving backward. Is it reversing? The reason to choose this topic is that it is important and a trending scientific discovery, important for students for the research point of view. In many questions are raising in the field of science about the uh, planetary dynamics and their long-term impacts. What will be their impacts for long term? And the least but not the last reason is that the students love to discuss and love to learn the topic related to science, earth, planet, their discoveries, their relation. Now we move towards its description, that the Earth's inner core slowed down significantly, so much that it may now be moving in opposite direction relative to the surface. And the question is that it could affect the magnetic field or the climate, seasons, or the length of our days and nights. In this video, we will break out and discover the major reasons for this mysterious phenomena related to the science. Before going to scientific reasons behind this phenomena, we will explore some Islamic reasons and Islamic point of view. In Quran Pak, at many places it has been described. I would like to share with translation that Allah is the superior power. He created this earth and heaven in 6 days. Then he established himself over the thrones and covered the nights with days. The meaning of this translation is that Allah has the control over the universe. He can do and He will do surely what He said in Quran Pak 1400 years ago. Science today, science and researchers describing this, but Allah has already mentioned in Quran Pak 1400 years ago, and it has also been proven by some ahadith that sun the day will come when sun will arises from west, not east. So might be this phenomena relates to that uh, concept. We will also discuss some scientific reasons. The first priority on our priority is the interaction between the inner core and the outer core. As we know that inner core is Earth is surrounded by the outer core, having mantle of the outer core, which can move due to the convection of heat that caused by the heat escaping from the core of mantle. And mantle is the layer between the outer and inner core. Here we can say that this movement of heat can generate the magnetic field and and it can affect the Earth's magnetic field, uh, due to which the liquid iron flow in the outer core. Um, Due to the movement of and flow of this liquid iron, friction and the electromagnetic forces can be developed, which can influence the rotation of the inner core. So here we can say, or we can say this might be the reason that if the outer core pattern changes, its movement pattern change, it can slow down the movement of the inner core. This is one reason. The second reason is that we can say that there is a gravitational coupling with the mantle. As we know that mantle is the uh, layer between the outer and inner core. So, so scientists says that inner core does not move in isolation. It means that it can interact gravitationally with the rocks of the mantle. So, over a long period of time, changes in mass distribution within the mantle due to plate tectonics and mantle convection or earthquakes can exert the gravitational force that can affect the inner core rotation. The third point, which we can say that there is a change in the Earth's magnetic field. It can also affect the movement or and slow down the inner core movement. Here we will describe that Earth's magnetic field is generated by the movement of liquid iron, as we discussed in the first point in the outer core. Because the inner core interacts with this field, any variation in the magnetic field strength or direction can alter the force acting on it. Some studies also suggest, and some scientists there says that the recent fluctuations in the magnetic field could be the reason to slow down the inner core rotation. The next point is tidal effect from the moon and sun. The gravitational pull of the moon and sun can also affect the entire Earth, including its core. Over million years ago, these tidal forces have gradually slowed down the Earth's rotation, a process known as tidal braking. So we can say the effect is more pronounced at the surface. It can also influence the core's movement. Either it is on surface, it will affect the movement of the core, either directly or through interaction with the mantle and outer core. The last point we will want to discuss is the thermal and density variations. As we know, inner core is gradually cooling and crystallizing as heat escape from Earth's interior. When heat escape from Earth's interior surface, the inner core becomes cool and crystallized. Changes in temperature and density within the core could modify its rotation. For example, we can say as part of the intercore solidify and the distribution of mass changes. Potentially, it can also change the rotational dynamics, which can also slow down the inner core movement. The next point we will discuss that viscous drag from the outer core. Since the inner core is solid while the outer core is liquid, as we know, and their interaction create viscous drag. There is concentration gradient. The friction between the moving liquid iron of the outer core and the solid inner core can also resist the inner core motion. It may also be the one reason for slowing down the movement of inner core. The next point is variations in core cooling and solidification rates. The inner core is gradually growing as iron crystallizes from the outer core. If the rate of solidification varies in different regions, it could create uneven mass distribution, affecting the balance of forces acting on the core and can change the rotation speed. And the geodynamic fluctuations can also be the reason, and seismic effects, earthquakes, mental deformations can also be the reasons. Next is gravitational asymmetry in the core. If the inner core is not perfectly spherical or has variations in density, gravitational imbalance can also cause the change in its rotation.